Namaskar दोस्तों, welcome to channel Toxicology on board. Today in this video we'll be discussing another DABT topic, that is statistical methods, power, standard error of mean and normal distribution. Okay, so let's directly dive into the question. The question is, which of the following statements regarding the concept of statistical power is or true? This question is taken from American Board of Toxicology recertification question paper 2000. Okay, so we need to understand the concept of this statistical power. Which of the following statements are applicable to that? So the first option is, the power of a study refers to the probability that statistical test of the result will identify a positive effect when one exists. Okay, so this is a direct definition of power of the study, its importance. The power of a study is the probability that it will lead to correct rejection of the null hypothesis. If you see H0 and H0 will be there, no null hypothesis, that statement. The significance level alpha is probability of committing a type 1 error, that is rejecting true null hypothesis. Option 4 is, to compute the power of a study, the investigator must specify all of the following parameters: alpha, beta, effect size, sample size, and variance. So the right answer will be in the green text. That is, all the four options are uh, related to the concept of this statistical power. So let us understand, quickly go through what is the definition of this statistical power. See, you have to understand, whenever you do certain research, to add certain value to that particular research, once you start collecting the data, statistics, application of statistics is very important. Based on what type of study, you will apply parametric test, non-parametric test, sample size, so variance, standard error of mean. These terminologies will be there. This concept will be there towards the end, once you complete the study, once you start getting the data. So we'll quickly run through. So based on those concepts also, some questions you will get in the ABT exam. So first we'll quickly go through what is statistical power. Statistical power or sensitivity is the probability that a test correctly rejects a false null hypothesis. If there is a false null hypothesis, this particular statistical power will be useful in rejecting that one, detecting the true effect or difference when one exists. That is nothing but 1 by 1 minus beta. Okay, we'll discuss what is alpha and beta also next slide. Statistical power represents the ability to avoid type 2 type of errors. So one question on errors also you'll get in exam: type 1 error and type 2 error. Type 2 error are false negatives. So this statistical power will avoid such type 2 errors with high power, because if the sample size is more, power statistical power is more, with high power, ensuring high likelihood of identifying the results, real results. False results you can avoid by using this particular concept. Okay, so we'll see what are the other important components with respect to, in continuation with the statistical power. If you look into the definition, the likelihood of finding a statistically significant result, if one exists, usually aimed at 80% or more, greater than 80%. If you look into the sample size, fourth option was about sample size. Increasing the sample size, like n up to 10. If you see OECD guideline, 28-day study, in that 6 per dose will be given. If you look into NDCT guidelines of Indian guidelines, 10 per 6 per dose will be there. If you go for a law, cancer study, it will be 50 per 6 per dose will be there. So as the sample size increases, no, so here that concept you have to keep in mind when you're reading this one. Increasing the sample size increases the statistical power, that is n value, as large samples provide higher sensitivity to detect the effects. If the sample size is, if there are certain students who are doing research at their academic level, no, their number of animals will be using less, because we are not submitting that data for regulatory submission. So n sample will be around 3 or 5. So if one or two animals are impaired or undergo some morbidity or moribund condition, then the whole study will not have any significance. Okay, so having a large sample size will help you in interpreting the results in a better way. Okay, so sample size is important, that you have to understand. That's why if you look into OECD guidelines also, or ICH or NDCT Indian guidelines for animal studies, I'm talking with respect to toxicology. Think those people who are clinical toxicologists, think about the patient size also. Okay, so So in that guidelines already they have defined 10 per sex per dose, 6 per sex per dose, 6 to 10 per sex per dose, or for number of animals for satellite groups or recovery group or TK group, like that will be there. Okay. So effect size, larger effect size is also there in the option 4. It was there, larger effect difference between the groups. Okay. So low dose, mid dose, high dose, the difference between the groups are easier to detect than smaller ones, resulting in a higher power. Okay. And significance level, that is alpha value is also there in the option. A higher level, for example 0.05 versus 0.01, increases the power but also increases the risk of type 1 error. So whenever the alpha value increasing, there is an increase in risk of type 1 error, that is false positive. Variance is also there in the option 4. High variability, that is standard deviation in data, reduces the power, making it hard to distinguish the real effect. So we are unable to differentiate between the false effect and the real effect. Okay. Why statistical power is important, that we will see. Power analysis. Researchers use this to calculate the necessary sample size before initiating the study, whether it is toxicology study or clinical study. Clinical study means number of patients that you will decide based on the which phase 1, 2, 3, like that. Coming to toxicology study, based on which guideline and which type of study and study duration and objectives. What are the objectives? So how much amount of this also matters. How much amount of parameters or blood withdrawal you are taking from the animals, that also decides this sample size. So the researchers use this to calculate the necessary sample size before a study to ensure they have a high chance of detecting an effect. Okay. Avoiding false negatives. So by using the statistical power, low power means n size is less or statistical power size is less, is high likelihood of missing true effects. What is the actual effect, we will not be able to identify. That is type 2 error, which is calculated as beta. So what is alpha, what is beta, you have to remember by the end of this video. Efficiency. Adequate power helps ensure the resources are not wasted, okay, on the studies that are unlikely to produce meaningful results. So this was about the concept regarding statistical power. So next question we'll see. This question is also taken from ABT, that is American Board of Toxicology Recertification Question Paper 2000. Which of the following statistical methods is or parametric procedure? So you have when it comes to statistical test, no, you have various types of test will be there. So you have parametric test and non-parametric test. Based this parametric and non-parametric test, this classification is based on the variation of the sample. Okay, if more likelihood sample is there, then you go for one type of test based on what how like two way ANOVA you're doing, a two group comparison you are doing. So like that different types of tests are there. So before applying the results and interpretation, you have to decide at the time of hypothesis only, you have to decide which type of test you are going to keep. Okay. So mostly I will see that Z test will be there in our acute 28-day toxicology study, and using some software like Dunnett software, like that. So we'll see parametric statistical, no, we haven't seen the options. So we have to identify the statistical methods which are parametric procedures. It's a direct question. If you know this particular classification, you will be able to do it. So first option is analysis of variance. Second option is Wilcoxon rank sum test. Third option is student t-test. Fourth option is Kruskal Valley test. This Wilcoxon rank sum test and Kruskal Valley test, no, here you can see KS test and here it is there. This diagram again, they comes under non-parametric. Coming to analysis of variance, ANOVA as well as student t-test, they comes under one sample variance, that is parametric test. This you have to remember. Okay. If you remember this particular classification, you will be able to answer this question. But with this question, we'll try to read other concepts also. So parametric statistical methods are procedures that assume that data follows a specific probability distribution curve. If you look into the curve will be there, no. So there is a whatever that distribution of population is there, no, it is having specific probability distribution. Commonly normal distribution or Gaussian distribution will be there, and rely on fixed parameters, that is they are depending on the average, that is mean variance, to define that particular population. How the population is there, it is well distributed or not, average is distributed throughout the population or not, that you have to sample, you have to decide. Okay. These parametric test methods are generally more powerful and precise than non-parametric test. Okay, this one sample test or two sample test, chi-square test. Okay, when assumptions are met, such are large sample size, independence, and homoscedasticity. Okay, so next we will see what are the key characteristics of examples of this parametric test. See, we are sticking only to the question. We are not discussing non-parametric test because I am not a statistical person. So we are only sticking to the question and question related concept what we can learn. So the core assumptions with respect to parametric tests is data must be normally distributed. If you look into the normal distribution curve will be there, no, data should be throughout, it will be normally distributed, independent, possess homogeneity of variance, equal variances across groups. Okay. Common examples are the t-test. Here you can see comparing averages, ANOVA, analysis of variance, and Pearson correlation are standard parametric tests. Suitability, best for continuous numerical data, that is body weight, and when sample size are sufficiently large sample size is there, then you have to go for this type of test. So when data violate these assumptions, heavily skewed, if the distribution curve is more towards rightly skewed or leftly skewed, or sample size is small or small sample size is there, n value is lesser, and parametric methods can be misleading, and non-parametric alternative, that is man-whitney u test you have to apply. Okay, so this you go back and read in detail about this type of parametric and non-parametric test. So now we'll enter into another concept. This question is also taken from American Board of Toxicology previous question paper. So question is, which of the following statements is or true about the standard error of mean? So whole video is with respect to statistics only. So we are discussing about SEM, that is standard error of mean. So what are the options we'll see? The standard error of mean, that is, sorry, the standard deviation is considered to be a better indicator of variability in individual measurements than standard error of mean. The SEM depends on both SD, standard deviation, and the original population and the size of the sample. SEM is used to state the uncertainty of the estimate of the average derived from a sample of population. SEM is direct estimate of variability of the data from which the average is calculated. The right answer will be in the green text. That is, SD is considered a better indicator of variability in individual measurements than standard error of mean. So there is a comparison between the standard error as well as standard error of mean. So here also you can pause the video and read. SEM, that is standard error of mean, depends on both SD, original population, as well as the sample size. It depends on N also. And SEM is used to state the uncertainty of the estimate of the average derived from a sample of a particular population. Okay, so very quickly we'll go through what are the important concepts that we can read with respect to SEM as well as standard deviation. So first we'll see what is standard error of mean. It measures the precision of a sample mean average as an estimate of true population average by quantifying how much of the sample average is expected to vary from the population mean. So there is a population mean will be there. So SEM is going to deviate how much it is going to deviate from that population mean that you have to see. SEM is calculated by dividing sample standard deviation, that is SD, by the square root of the sample size. Whatever the n size is 50, 100. So square root of this n standard deviation divided by square root of this sample size will give you standard error of mean. Okay, so what are the important aspects with respect to standard error of mean? SEM, it will evaluate the reliability of the sample mean. A smaller SEM indicates a more precise estimate of the population mean. Okay, as the what is the impact, the sample size impact? As the sample size increases, n value increases, SEM decreases. So it is inversely proportional, meaning the sample mean clusters closer to the population mean. So whenever you see this particular this normal distribution curve will be there, no. So whatever this sample cluster is there, no, it is more closer towards this particular population mean. And the difference between the comparison between standard error of mean and standard deviation is, it will describe the spread of this individual data points, 1 2 3 4 data is distributed over throughout, no, within a sample, while the SEM describes the variability within particular sample averager. Okay, so what is the application of this SEM is, it is used to calculate the confidence intervals. For example, 95% confidence interval is there, plus or minus 2 is the standard error of mean. Okay, it can be 97, it can be 93 also, like that. Okay, so what are the important differences between SD and SEM is this standard deviation, no, it will measure the dispersion of the data points. You have various data points when you plot the particular graph. So how the data is distributed, that will be, you will get it from the standard deviation. And in the case of standard error, from each point the difference from the average, you will be getting. So measures the precision of the sample mean. SD, standard deviation, is relatively unaffected by the sample size, whereas standard error of mean decreases as the sample size decreases, inversely proportional we have seen. So SEM represents the variability of the sample mean, whereas SD, it will represent the variability of the individual data points. Each data point, how it is distributed throughout, that it will give standard deviation. Okay, so that was about third question. Now another question we will discuss with respect to statistical topic only. So this question is also taken from ABT only. So in a normally distributed population, see, this is how the population is normally distribution. If it is skewed towards left side or it is skewed to right side, then you have to apply non-parametric test. Okay, in a normally distributed population, plus or minus 1 standard deviation, plus or minus 1, the about the mean represents approximately what percentage of the population. So the options are 10%, 20%, 50%, 70%, 90%. The right answer will be green text, that is 70%. How the concept we will see now. In a normally distributed population, the range of plus or minus SD, here in the question also you can see, about the mean represents approximately 68.27% of the population. How we are getting the 68.27, that we will see now. Understanding this, first let us understand what is this one normal distribution. As I told you, no, if it is neither skewed towards left or neither it is skewed towards right, this is the average, this is the mu standard deviation, and it is equally distributed throughout the population. So normal distribution or Gaussian distribution is probability distribution that is symmetric about the mean in either side of the mean mu. In this distribution, data is more frequent near the average, that is near the mean, then far from the mean. Okay, the total area under the curve represent, this particular area under the curve represent 100% population. So if you apply this empirical formula, no, empirical formula, it is also known as 65, 95, 99.7 percentage rule. And coming to our this thing, option 70% is there, no, it falls under this 68. Defines how data is distributed across standard deviations in a normal curve. See, first one is, if the plus or minus standard deviation is 68.3% of the data, okay, plus or minus standard deviation of 95.4% of the data, and plus or minus standard deviation of 99.7% of the data. Here you can see you have to minus 1 from here, minus 1 from here, 100 from the 100, you'll get this 99.7, like this only 2, and like this only 3 you will be getting. So this is how the option will be 68.3%. Okay, so plus or minus 1 standard deviation. So actually these concepts are little bit because not every toxicologist will be applying statistics. In the team you will be having separate statistical person will be there who will be doing the interpretation of or application of, or now we have even softwares also which will be doing. Earlier there were questions, but when a person is planning a certain study, no, the researcher, he should be knowing what type of statistical test he is going to apply, what will be his sample size, what is the average. Okay, final interpretation of data, whether the results are statistical significant or they are biological significant. To interpret all these things, little bit of knowledge, basic information about statistics that you need to have. Probably the examiner also expecting the same from when they draft the questions. So having an awareness, knowing these terms is good. So if in case you get a question, you will be able to, by at least looking into at the options, you will be able to answer the question. Okay, thank you so much. Be curious. For any questions, you can always write a mail to arya.priyanka18@gmail.com. All the best for your exam.